Hello, my name's Gabe. For this problem, we're asked to analyze and sketch the graph of g of x equals 6 arcsine of x minus 2 over 2 squared. So before we start worrying about finding the x-intercepts and y-intercepts and looking at the derivatives, let's go ahead and let's first establish the domain of the function. So we know that the domain of just arcsine of x is from -1 to 1. So first, we want to note that x minus 2 over 2, that quantity squared, is always going to be greater than 0. So when we're setting up an inequality to find our domain, we want to set up 0 is less than or equal to x minus 2 over 2 quantity squared, and we want this to be less than or equal to 1. Now here, we can go ahead and solve this inequality, and what we find is 0 is less than or equal to x is less than or equal to 4. So the domain of our function is from 0 to 4. The next thing we would like to concern ourselves with is the x-intercepts. So to find the x-intercepts, we'll want to set our function equal to 0 and solve for x. So we'll solve the equation 0 equals 6 times arcsine of x minus 2 over 2, this quantity squared. So we can divide both sides by 6, and we have 0 is equal to arcsine of x minus 2 over 2 squared. And we know that arcsine of just x is equal to 0 when x is equal to 0. So when we want to solve this equation, all we have to do is solve the equation x minus 2 over 2 squared equals 0. And when we solve this equation, we end up with x is equal to 2. So this means we have an x-intercept at the point 2, 0. Now to find the y-intercept, we'll find g of 0, which is 6 times arcsine of 0 minus 2 over 2 squared, which is equal to 6 times arcsine of 1. Now arcsine of 1 is pi over 2, so g of 0 is 6 times pi over 2, or 3 pi. So our y-intercept is the point 0, 3 pi. Now we'll want to take our first derivative. I've already found the first derivative and simplified, and we end up with g prime of x is 12 times x minus 2 divided by the square root of x times 4 minus x times x squared minus 4x plus 8. So we'll want to look at both where this derivative is equal to 0 and where it's undefined. So if we set g prime of x equal to 0, we know this is only going to be true when the numerator equals 0. So g prime of x equals 0 when 12 times x minus 2 equals 0. So we know this is only true when x is equal to 2, which means x equals 2 is one of our critical numbers. And we've actually already evaluated our function when x equals 2 because we know it's an x-intercept. So we have a critical point at the point 2, 0. We also have that our derivative, g prime of x, is undefined when x equals 0 and when x equals 4. But these are both our endpoints of our interval, so we're going to go ahead and we're going to look at these when we create our table. Next, we have our second derivative. So g double prime of x ends up becoming and becomes simplified down to 12 times x to the 4th minus 8x cubed plus 24x squared minus 32x plus 32, all divided by x times 4 minus x times x squared minus 4x plus 8, all raised to the 3 halves. So again, it's easy to see that the second derivative is undefined when x equals 0 and when x equals 4. Again, we'll address these when we create our table. But we can use a graphing utility to verify that the numerator of our second derivative is never equal to 0. Now that we have this information, let's go ahead and create our table. So the first table is going to take care of x between 0 and 2. Now, since 2 is a critical number, we're going to want to ask ourselves what happens when x is equal to 2. And then our next interval will be from 2 to 4. So we're looking at the x values between 2 and 4. So we can't evaluate our function at all the values between 0 and 2, but we can evaluate our function g when x is equal to 2. And as I stated earlier, we already know that g of 2 is equal to 0 because the point 2, 0 is an x-intercept. Next, we'll want to look at our derivative evaluated on the interval from x equals, well, from 0 to 2. We'll want to look at our derivative when x equals 2, which we already know to be 0. And we'll want to look at our derivative on the interval from 2 to 4. So if we choose a value between 0 and 2, say x equals 1, and we substitute that into our derivative, what we'll see is that the derivative is negative. So this means that our function is decreasing on the interval from 0 to 2. And if we substitute a value between 2 and 4, say 3, into our derivative, we'll see that that's positive. This means that our function is increasing on the interval from 2 to 4. Next, we'll look at the second derivative. So if we choose the same test value between 0 and 2, 1, and substitute this into the second derivative, we'll see that this is positive. If we substitute 2 into the second derivative, that will also be positive. And if we substitute a value between 2 and 4 into the second derivative, let's say 3 again, we'll also see that that's positive. So now we can conclude what we learned from this table. First and foremost, we learned that on the interval from 0 to 2, our function is decreasing, concave up. So we're decreasing because our first derivative is negative, and we're concave upwards because our second derivative is positive. We know that when x equals 2, our derivative is 0, and our concavity is positive. This means we have a relative minimum from the second derivative test. And finally, on the interval from 2 to 4, our first derivative is positive, which means we're increasing. And our second derivative is also positive, so again, we're concave upwards. So now let's go ahead and let's try to sketch the graph of our function. So we have our x-intercept at the point 2, 0. We have our y-intercept at the point 0, 3 pi. And now we have somewhat of a basic idea as to what our graph is going to look like from this table. But let's also ask ourselves, what happens when x equals 4? So what happens when x is equal to our right endpoint? So g of 4 is going to be 6 arcsine. We're going to have 4 minus 2 divided by 2, this quantity squared. So we're left with 6 arcsine of 1. And again, we know that arcsine of 1 is pi over 2. So we know that g of 4 is going to be 3 pi. So we know that g has to pass through the point 4, 3 pi. So now we have 3 points of our graph. Let's use the information that we gained from this table to sketch the rest of our graph. So on the interval from 0 to 2, we're decreasing, concave up. Now once we hit the point 2, 0, we've obtained a relative minimum. And then on the interval from 2 to 4, we're increasing, and our concavity is still upwards. So we're going to increase up to the point 4, 3 pi. And there we've sketched the graph of our function g of x equals 6 arcsine of x minus 2 over 2 quantity squared. Thank you.